Chapter 14, Problem number 7. A police car with a 600 Hz siren is traveling on the same street as a motorcycle. The velocity of the two vehicles and the distance between them are given in each figure. And we are asked to rank the frequency of the siren as measured by the writer. So our basic principle here is going to be a Doppler effect. It's going to say if the range is closing, meaning they're getting closer together, then the frequency should be higher because waves are piling up more rapidly. And if the range is opening, meaning they're getting further apart with time, then the frequency should drop because there are fewer wave impacts per second as the motorcycle runs away. So notice the range does not actually matter, only what's happening to it. So we go up here and we say in part A, they're closing, right? It's closing at 10 meters per second. In part B, it is also closing. In part C, the range is opening. And then in part D, there's no change. So we can immediately say that we'll end up with D is in the middle, and then case C, the frequency is lower because the range is opening. The question is, what happens, which of these wins sort of in case A or case B? Here we have to go back and look at the actual cases. Here, the police car is gaining 10 meters per second on the motorcycle. The range is decreasing by 10 meters per second. But over here, the range is decreasing by 20 meters per second because both of them are taking away 10 meters per second. So B is going faster, which means it has a stronger Doppler effect than A, which is more than D, which is more than C. There is no Doppler here because the relative speed is 0.